Welcome. I am Alfredo Reder from the Euro-Mediterranean Center on Climate Change. In this video, we will talk about something very important, how we can get useful local climate information. We often hear about global climate change, but when it comes to planning a new building, protecting farmland, or adapting cities, what really matters is local climate information. What will happen to precipitation in your valley? Will summers get hotter in your town? To answer these questions, we need accurate climate data that is specific to your region. That's what we'll explore together in the following minutes. Climate data usually comes from large-scale models that simulate how the Earth's climate behaves. These models help us understand the big trends across continents or oceans. But these models work on a very large scale. They might describe the climate over hundreds of kilometers, so it's too big to show what's happening in a specific area. This is where a process called downscaling comes in. Downscaling helps us take information from global models and make it more detailed, so it fits the local reality better. There are two main ways to do this. One uses regional climate models, which simulate the climate in more detail for a smaller area. The other uses statistics, meaning it compares model data with historical observation and adjusts it to match local pattern. Both methods are useful and often they are used together. In our activity, we focused on the statistical method, using a technique called empirical quantum mapping. Don't worry, this is simpler than it sounds. Imagine you have climate data from a large-scale model, and you have also past records for your area, things like temperature and precipitation collected over the last 30 years. These records can come from weather station or special dataset reanalysis that combine model with observation. The statistical downscaling compare what the models say about the past with what actually happened locally. It learns the differences and then uses that information to adjust future projection. But it does more than just correct the data. It also lets us zoom in, going from very large areas to a much finer detail. Let's look now at how this data is being used in practice. Thanks to the downscaling work, we now have high resolution information for the 6 case study across Europe for the RethinkAction projects. And this information not only for basic climate variables like precipitation, temperature, and wind speed, but also for more advanced climate indicators. These indicators serve as proxies for hazard, helping us understand when and where climate conditions might become more dangerous. For example, we can look at tropical nights to understand heat stress in cities. The number of consecutive dry days shows us the risk of drought. The intensity of heavy rainfall points to flood potential, and the reference evapotranspiration, which measures how much water is potentially lost from soil plants, is a key indicator for agriculture. These data are freely available and visualizable in two formats: maps, which show how climate indicators vary across space, and time series, which show how they change over time. Thanks to downscaling, we can now turn global climate models into useful and local information. This helps community plan better, act earlier, and build a more resilient future. We invite you to explore the RethinkAction tools, consult the dataset on Zenodo, and use these resources to support smart decisions in your area. Thank you for watching.